Welcome to Mathematics for All by NeoMath. This is Class 9 NCERT Mathematics, Chapter 2 Polynomials, Exercise 2.1. All these topics were discussed in Introduction to Algebra Part 1 and Part 2 video. The link is given in the description box. Please check. Let's do some practice questions. Which of the following expressions are polynomial? First question, x cube plus 5x plus 2. Here we have to check the power of the variable. If it is a whole number, then the given expression is a polynomial. Here we have three terms, x cube, 5x and 2. The power of variable x in the first term is 3. The power of variable x in the second term is 1. The power of variable x in the third term is 0. 2 is a constant polynomial. It can be written as 2 into x power 0. Anything power 0 is 1. So the power of the variable x in the third term is 0. So this expression having only non-negative integral powers of x. That is whole numbers only. So it is a polynomial. Question number 2. 4t square plus 1 by 6t plus 2 root 3. Here we have three terms. 4t square, 1 by 6t, 2 root 3. The power of variable t in the first term is 2. The power of variable t in the second term is 1. The power of variable t in the third term is 0. So this expression having only non-negative integral powers of t, that is whole numbers, so it is a polynomial. So third question, z plus 5 by z plus 1. This can be written as z plus 5z power minus 1, isn't it? Plus 1. So here we have three terms, z, 5z power minus 1 and 1. So the power of variable z in the first term is 1. The power of variable z in the second term is minus 1. The power of variable z in the third term is 0. This expression has a term having negative integral power of z. Isn't it? Minus 1 is there. So it is not a polynomial. It should have non-negative integral power of z. Non-negative integral power of the variable. So it is not a polynomial. Fourth question. Cube root of x plus 4. So this can be written as x power 1 by 3 plus 4. Cube root of x can be written as x power 1 by 3. Fourth root of x can be written as x power 1 by 4, isn't it? Yes. Here we have two terms, x power 1 by 3 and 4. The power of variable x is 1 by 3. The power of variable x in the second term is 0. This expression has a term having a rational number as power of x, isn't it? So it is not a polynomial. So exercise 2.1, question number 1. Which of the following expressions are polynomial in one variable and which are not? State reasons for your answer. First part, 4x square minus 3x plus 7. Here we have two steps. Step 1, check whether the given expression is polynomial or not. If it is polynomial, then we have to check whether it is polynomial in one variable or not. Okay, first step 1, we have to check whether the given expression is polynomial or not. So if the powers of the variable are whole number, then it is a polynomial. Here we have three terms, 4x square, minus 3x and 7. So the power of variable x in the first term is 2. The power of variable x in the second term is 1. The power of variable x in the third term is 0. So this expression having only non-negative integral powers of t, that is a whole number. So it is a polynomial. So this is a polynomial. This expression is a polynomial. So we can go to step 2. Check it is polynomial in one variable or not. If it has only one variable, then it is polynomial in one variable. 4x square minus 3x plus 7 has only one variable x. So it is polynomial in one variable x. Second part, y square plus root 2. Again, step 1, check whether the given expression is polynomial or not, and then if it is polynomial, then we have to go to step 2, check it is polynomial in one variable or not. Here we have two terms, y square root 2. So the power of variable y in the first term is 2, the power of variable y in the second term is 0. This expression having only non-negative integral powers of y, so it is a polynomial. So y square plus root 2 is a polynomial, so we have to go to step 2 to check whether this polynomial is one variable or not. So it contains only one variable y, so it is polynomial in one variable y. Part 3, 3 root t plus t root 2. This can be written as 3 t power 1 by 2 plus t root 2. Step 1, check whether the given expression is polynomial or not. Here we have two terms, 3 t power 1 by 2, t root 2. The power of variable t in the first term is 1 by 2, which is a rational power. The power of variable t in the second term is 1. This expression has a term having rational power of t, so it is not a polynomial. So we need not to do step 2. Fourth part, y plus 2 by y. This can be written as y plus 2 y power minus 1. Step 1, check whether the given expression is polynomial or not. Here we have two terms, y and 2 by y, that is 2 y power minus 1. The power of variable y in the first term is 1, the power of variable y in the second term is minus 1. This expression has a term having negative integral power of y, so it is not a polynomial. So we need not to do the second step. Part 5, x power 10 plus y cube plus t power 50. Step 1, check whether the given expression is polynomial or not. Here we have three terms, x power 10, y cube, t power 50. The power of variable x in the first term is 10, the power of variable y in the second term is 3, the power of variable t in the third term is 50. This expression having only non-negative integral powers of x, y and t, so it is a polynomial. Step 2, check it is polynomial in one variable or not. Here we have three variables x, y and t. So it contains three variables x, y and t, so it is not polynomial in one variable, it is polynomial in three variables x, y and t. Exercise 2.1, question number 2, write the coefficient of x square in each of the following. So in this question we have to write the coefficient of x square, that is the numerical part of x square term. First question, 2 plus x square plus ex. The second term in this given polynomial is x square. So this x square can be written as 1 into x square. We know that variables with no number have a coefficient of 1. So the coefficient of x square is 1. Second part, 2 minus x square plus x cube. So the x square term is minus x square. This can be written as minus 1 into x square. So the coefficient of x square is minus 1. Third part, pi by 2 x square plus x. The first term is x square term. So pi by 2 x square. This can be written as pi by 2 into x square. The coefficient of x square is pi by 2. Fourth part, root 2x minus 1. Here there is no x square term. So this can be written as root 2x minus 1 plus 0x square. So the x square term is 0x square. So this can be written as 0 into x square. So the coefficient of x square is 0. Exercise 2.1, question number 3. Give one example each of binomial of degree 35 and of monomial of degree 100. So binomial of degree 35 and monomial of degree 100. Binomial means it should have two terms and degree should be 35, that is the highest power of the variable should be 35. So we can write x power 35 plus any value, 5, 5x, anything we can write. Okay, Next, monomial of degree 100. Monomial means there should be only one term and the degree, that is the highest power, should be 100. So we can write y power 100. Exercise 2.1, question number 4. Write the degree of the following polynomials. How do we find out the degree? The highest power of the variable in the given polynomial is the degree. First part, 5x cube plus 4x square plus 7x. The highest power of the variable x in this polynomial is 3, so the degree is 3. Second part, 4 minus y square. The highest power of the variable y is 2, so the degree is 2. Third part, 5t minus root 7. The highest power of the variable t is 1, so the degree is 1. Fourth part, 3. 3 is a constant polynomial. This can be written as 3 into x power 0. So the degree is 0. So the degree of non-zero constant polynomial is always 0. Thank you. Exercise 2.1, question number 5. Classify the following as linear, quadratic and cubic polynomials. So what is linear polynomial? If the degree of the given polynomial is 1, then it is linear polynomial. Quadratic is, if the degree of the given polynomial is 2, then it is quadratic polynomial. If the degree is 3, then it is cubic polynomial. So first part, x square plus x. First we have to find out the degree. So how do we find out the degree? The highest power of the variable is the degree. Here the highest power is 2. So the degree is 2. So it is quadratic polynomial. Second part, x minus x cube. The highest power of the variable is 3. So the degree is 3. If the degree is 3, then it is cubic polynomial. Third part, y plus y square plus 4. The highest power of variable y is 2. So the degree is 2. If the degree is 2, then it is quadratic polynomial. Fourth part, 1 plus x. The highest power of variable x is 1, so the degree is 1. If the degree is 1, then it is linear polynomial. Fifth part, 3t. The highest power of the variable t is 1, so the degree is 1. So it is a linear polynomial. Fifth part, r square. The highest power of variable r is 2, so the degree is 2. So it is a quadratic polynomial. Part 7, 7x cube. The highest power of variable x is 3, so the degree is 3. So it is a cubic polynomial. So in the next video we will discuss chapter 2, Introduction to Zeros of Polynomial. Thank you.